All right, here's your video for the force body diagram that I said I would make. Sorry it took so long. My weekend was absolutely chaotic. So when you look at this assignment, there are some keywords to pay attention to that will help you with some of the questions at the bottom of the boxes. Things like constant speed, motionless, rest. Those are all examples of things that have no net force, which means they're not accelerating. If you have something saying that the speed is changing or things like that, let me see if I can find an example. The box is accelerating. This would be an example of one that has a net force, because in order to accelerate, you need a net force. Let's see. Constant speed. So this one wouldn't have a net force. So think of those words when you start working on some of these. Now, if you look at, let's say number 2, for example, it says a box slides at constant speed to the right with friction acting against it. So this is a constant speed, which means it doesn't have a net force. And we can expect all of the forces to cancel each other out, depending on what axis they're on. So if we're having a box slide to the right with friction acting against it, we're going to have some applied force going to the right. So it'd be an arrow going this way with FA. Friction would be going the opposite direction. So we would have a vector going to the left with FF if you wanted to use it. And then anytime you're resting on an object or the ground, you're going to have a normal force. So you're going to have a force or Fn going up, and then the gravitational pull or Fg is going to be going down. So those are going to be the 4 arrows you would use along with the forces they would be. So this one would have 4 forces acting on it, 2 horizontally and 2 vertically. Do all the forces cancel out? We can say yes, because there's no net force, meaning they would cancel each other out. If we're at, if we have a net force of 0, we are at equilibrium. So anytime you put yes to forces cancel out, yes, it would be an equilibrium. So both of these would be yes, or they would be no. They would never be different. And then is there not a net force? We said no. And then since we don't have one, we don't have to worry about what direction it's going into. Okay, so that's an example of kind of how to answer those bottom ones. Now, if we look at number 6, which I know you mentioned, this one is suspended from a ceiling with 2 ropes. The only thing that's different with this is since we have 2 ropes, the ropes both have an X and Y axis vector. So you're going to have a certain amount of force pulling up, and a certain amount of the force is going to be going towards this horizontal direction. So you're going to have horizontal and vertical components to this rope as well as this rope. Kind of like a triangle, if you want to think of it that way. And those 2 ropes, or the cumulative forces of those ropes, is going to oppose gravity, which is going to be pulling down. And then you'd answer this just similar to how we did with the last problem. So take a look at those, see if that helps a little bit. If you are stuck on any other ones, just shoot me an email and I can help you. But just remember, if the forces cancel out, then it would be at if the forces cancel out, it'll be at equilibrium, meaning we have no net force. Okay, so those are always going to go together in that aspect. It's just kind of different ways of saying it, if you will.